Hi, in this video, I'm going to give a quick overview of how to define a discrete signal or a digital signal in Siemens HMI as an alarm. Unfortunately, it's not that straightforward as we would think that a boolean is getting on and off and we will getting alarm on the HMI. It's a bit complicated in case of Siemens HMI. We have to think about the limitation in Siemens HMI alarms is that the tag here always needs to be a word. So defining a Boolean signal or discrete is a little bit of tricky process. So let's get started. As an example, I have a pump, actually two pumps, and we would like to create an error or an alarm signal if there is an overload from any of these pumps. So to do this, the best way is to create first a global data block, which is here. The name is 14 errors and warnings, and some variables are created here which are basically bool. This is error pump, one of the pumps. If the overload comes here, then I would put this true, and if not, then I would put it false. And this is error for the second pump. Let's go have a look in the function block. If the overload comes from this pump, then we will write this variable which we just had a look in this global data block. Okay, so this is done, defining or declaring and assigning the value of the pump overload to the global data block variables. The global data block is also defined here, and then we need to go to the HMI section. Let's close this all, and we have the HMI, and in the HMI tags we have to create another tag table and name it as a pointer to data block 14, because the data block we created to store our errors or warnings, the number of the data block is db14. So let's open this. Here is the trick that we need to use absolute addressing in this case. So if we go here and properties, and you can see that here we have used absolute access. So here for the two Boolean signals, I created an array 0 to 1 of word. So it's a data type of word, and the first one is also a word and the second one is also a word. So we will use these two as Boolean address tags for the HMI alarm. So when this is done, after we created the pointer, let's go to the HMI alarms, and here we will create an alarm. For example, the first one, pump conserving overload alarm, what text this would show and the errors, and this is the tag. And here is the trick that we will go to the pointer we just have seen here, to the pointer, and then what some people might do the mistake that we would go here and you would like to select this one. No, you cannot do it that way. We have to go here and then just select this one and press, okay, it's not showing, it's the right side. There will be a tick sign, and put the tick and then select this one, and as you can see it has gone null. So because I didn't select anything, so let's put Control Z. Yeah, it comes back. And here when we see the trigger bit, so the first absolute address of the pointer HMI tag table is db14 dbx 0.0. Now you might be wondering, why is it 8? So let's move this one. You can see the difference. If you go down, 7 6 5 4 3 2 1 0, so that's actually dbx 1.0. and if we go to 8, then it dbx 0.0, and dbx 0.1 is 9. So let's have a look in this Excel table. We have word 0 here. A word consists of 2 bytes, first byte, second byte. 1 byte consists of 8 bits. We have the bits here, and this is the most interesting part of Siemens, that just putting, instead of putting this one 0.0 to 0.7 and then 0.1 to 0.1.7. 0.0 actually starts from the trigger bit index 8. So when 8 means 0.0, not 1 means 0, I'm 1.0. So this is the tricky part. And then let's also explain you this. When we have a 9-bit system, the maximum value which it can hold is 256. So when we will have some value in between 256 and 128, then it will actually generate the alarm with this bit. And when we will have a value between 512 and above 256, then the alarm it will generate with the trigger bit index 9, which is actually memory location M0.1 inside the word. So let's remember, a word is with 2 bytes and 1 byte has 8 bits, and there is this concept also you need to grasp, that always in Siemens it starts the opposite way around. The 8th one is the first one. In the same, for example, MW30, MW30.0 starts from bit index 8, and then 31.0 of the first bit of the second byte starts from trigger bit index 0 here. Okay, so here we have it. So let's run our HMI. Select the HMI online simulation with tag simulator. It's a post ECM conserving and washing station from Extrude Hone, and I'd like to minimize this one. Okay, so here is it. Let's go to the screen. I have the screen here, and we would like to see the alarm. In my case, let's select this one. We have this. Let's put this a little bit. Yeah, so we have error pumps overload 0 1. So let's generate a signal which will bring us the error signal. So we selected 0, and we have a value. We can set the value here. So remember that, as I said, for the first one it is 0.0, trigger bit index 8. So the max is value is 256. So when we get 256, the error signal should come. 256, and as we see the alarm, we can see the alarm here, and it's showing conserving pump overload. So what we can do, let's put it back to 0, enter. It's gone. As you can see, it's gone, but we still have to acknowledge. We acknowledge, and it's gone. And set value 512. Okay, so rinsing pump overload, which is this one, rinsing pump overload. Okay, so how this absolute addressing was db14 dbx 0.0 db14 dbx 0.1. so we are actually pointing towards a bit using a trick. So the system thinks we are actually defining a tag which is a word. Okay, yeah, thanks for watching.